one of the things that I have seen for e-textiles, just while we're on, is, and it's not something we've got at the moment, but you can get little LiPo batteries which charge off things like a USB port and stuff. And I've seen those mounted onto to products for e-textiles, so that might be something that, you know, people are looking to run lots of LEDs that we could look into. Okay, so what I'm going to talk about now is these sort of three products here. You may have, you may have seen us on our website. We've only been selling for a little while, but I think sometimes it's better to explain to people what they are, because it's a bit hard to grasp, I think, off the web. But so I'm going to do some close-ups and show you what they all are. So basically, there are a range of we have two types of force sensing resistors, and then we've got a third unit which is actually used for measuring weight. Now, these are the kind of things you may want to use with some kind of microcontroller project, where, let's just take one of these out so we can have a look. Where you're trying to measure some way, some bend. So this is a flexible resistor. So if you have a look at it here, it's got a flex to it. And the resistance of this device changes depending upon the amount of flex that's applied to the device. It's got a simple two-pole connector on the end, so you can feed this into your microcontroller as part of a potential divider. I'm not sure if people understand what I mean. Let me just do a quick write up on the board. So if you've got something like a PIC or a Genie board, so this is your processor, this is your power supply. You can have some kind of potential divider where one of these resistors is fixed, and the other one would be this variable FSR or force sensing resistor, and then would feed the center point into an ADC or analog port of a PIC or a Genie. And what would happen is, as the value of this force sensor resistor changes with flex, the voltage that's fed into this pin will vary. So you can get your processor to measure this change of flex by taking an analog reading on that pin. I'm sure if you understand PICs a little bit or using them, you'll understand what I'm talking about here. It's quite a simple thing to do. So what these are allowing us to do, I'm just going to come back down. Sorry. So we can use these as an input to measure angle or flex. Apparently, these were used in a glove that Nintendo developed years ago, where you could move your fingers in the glove, and these were part of it. And as your fingers moved, it bent the sensor, and you could detect that. So you could detect some gripping motion or something else, or you might have something you were concerned about if it's over flexing, and you wanted to measure it. So you could stick these down onto the device you wanted to measure the angle of. Like I say, it's quite a neat little device. I think I'm sure that it could be quite useful for a lot of applications. We've got those in two different lengths. It's American, so I think we've got a 4.5-inch sensor. And we've also got a 2.2-inch sensor. We have a shorter version. Now these are very similar, but slightly different. As before, the previous one measures flex. This one measures as a resistance that changes as you can get it out. As you press on the device. So you can see here there's like a sensing pad. These could be stuck down. You double-sided tape on the back, you could stick that onto something, or build it into part of an overlay or something, and you can make it into a very thin or switch. As you press onto that pad, its resistance changes. So again, you could use this, as I showed you a minute ago, on the whiteboard, where you could feed that into some kind of microcontroller, and you could use it as a switch, or some kind of, you could detect if something was placed on top of it, or something was pressing on it, because that's a sensor, or you stood on it. Those kind of things, all kind of it's quite a neat little resistor, really. Now they're not ultra high accuracy, so you couldn't use this to give a high accuracy read on something like weight as part of a set of scales or something, but it would allow you to detect if it was being pressed or compressed. So that's quite a neat little resistor, which again, I'm sure if you're doing some microcontroller or PIC, Genie, Arduino style projects, these could be really useful. And then lastly, I thought I'd show you this. Now, let's just cut this open. this is a sensor. It's got a 3-wire interface. So there's your power signals and then the output. Maybe I can unravel it. Done that a little bit too quick. There we go. You can't actually feel this give at all. These are high accuracy sensors for measuring weight, and these are, if you've got a set of home scales that you know, using your kitchen or your bathroom that measure weight, and this can measure up to 50 kilograms. So probably not a set of bathroom scales for most people. You might be okay for measuring all the weight of children, but more the kind of scales you get in a kitchen. These give a high accuracy output depending upon the weight that sits on top of the device. So yeah, again, these could be integrated into some kind of microcontroller project or something where you wanted to accurately sense weight in some way. So yeah, it's just you can't really see it move at all, but there's a cantilever effect. We've got a little blurring. You can't physically see it move, but it is actually sensing force on the top of this point here. So neat little sensor. I'm sure there's lots of things we could do with those. So there's some new things we've just added to the catalogue, and I'm sure that they might be of interest to a lot of you. Okay.